Hello, everyone. This is 3.2. We are going to learn about different rules of differential functions. And the first one we're going to look at in 3.2 is we're going to learn about exponential and logarithmic functions. All right, so let's start with by looking at the rules of derivatives of exponential functions. So derivatives of exponential functions, it's pretty easy. Right, so if you have the e to the x when your base is e, Euler's number, right? The differential or the derivative of e to the x is just itself, e to the x, right? It's the same thing. So it's very nice to work with e to the x. And furthermore, if you have e to the some other power k times t, where k is some constant, right? Then this is equal to k times e to the power of k of t, right? Where k is a constant. Okay, and if you have some other base, right, some other constant base a, and you have a to the power of x, then this is ln a times a to the x. Okay, so if your base is e, then ln e is just 1. So that's why when we look at the derivative of e to the x, it's just itself. All right, so let's look at a first example. Example 1, differentiate 2 times 3 to the x plus 5e to the x. All right, so to take the derivative of everything, 2 times 3 to the x plus 5 times e to the x, it's the same thing as taking them separately, right? So dx, 2 times 3 to the power of x, plus dx, 5 times e to the power of x. All right. And as we saw from last part, this extra constant can be brought out to the front, right? So we have something like this, right? We can rewrite this as 2 times d dx of 3 to the power of x plus 5 times d dx of e to the x, right? And then we know what these two are, right? Differential of 3 to the x and e to the x. That's just 2 times ln of 3 times 3 to the x plus 5 times, and the derivative of e to the x is just e to the x. Okay, and that's it. All right, next let's look at the derivative of ln x. Now, derivative of ln x is also pretty straightforward. It's just 1 over x, right? d dx of ln x is just 1 over x. So in this case, we can think about this as when you're taking the derivative of the natural log of x, it pushes the x down to the denominator, right? Pushes whatever you have in here down to the denominator, and that's it, right? So we can take a look at the graph, ln x, and then the derivative is just 1 over x. All right, let's take a look at this example together. Suppose $1,000 is deposited into the bank account paying 8% annual interest compounded continuously. A, find the formula f of t years after the initial deposit, and B, find f of 10 and f prime of 10. Okay, so first we need to write out the formula for continuous compound interest, which is A is equal to P times e to the RT. All right, so this total is going to be our function, right? So f of t is p is 1,000, right? We started with $1,000. E to the RT, R is 8%, which is 0.08 t. Okay, so that's just part A, right? Part A, finding out the formula, right? This is a continuous compound formula from last chapter, I think. Right, P is your principal, R is the rate, and T is how long you leave your money in there. All right, let's look at part B, find f of 10. Okay, so plug in 10, 1,000, e to the power of 0.08 times 10, which comes out to 2,000, about 2,000 225.54. Right, this is in the amount of dollars. Okay, so what does that mean? That means after 10 years, we will have this amount of money in our account, right? We will have $2,225.54 in our account, which is pretty good, right? After 10 years, you have earned more than double. All right, now second bar, find f prime of 10, right? So first we need to find f prime, right? Which is the derivative with respect to t of 1000 e to the 0.08 t, right? And then we can bring out the 1000 and then multiply that by derivative of e to the power of 0.08 t. Now, if you remember the formula from earlier, derivative of e to the kt is k times e to the power of kt. So you just need to multiply that extra constant in the front. Right, so multiply by 0.08 and then copy whatever the function is after that. And then what do we have? There'll be 80 times e to the power of 0.08 t. Okay, so that's f prime. 80 times e to the power of 0.08 t. Then f prime of 10 is just plug in t, which comes out to 178.04. Okay, so what does this value mean? Right, this 178.04. Now, they are actually amount of money, the change of amount of money at year 10. That means at year 10, we're going to be earning this much extra interest. We will earn 178.04 at that exact point, right? At year 10, the amount of money is growing at the rate of about $178 per year, right, which is what's being said right here. Okay. All right, 3.3, we're looking at something called the chain rule. So chain rule means when we are taking derivatives, we have to take into account of some little function that's in there. So let's take a look at some introduction. All right, so let's take some time to look over the definition here, right? If y is f of z and z is g of t, right? So we have actually two types of function. Think about a compositional function, if you will, like what we have in this case, right? A compositional function. Oops. Y is equal to f of g of t. Then the derivative of y, dy dt, is dy dz multiplied by dz dt. Now, this notation can be a little bit confusing, but let's take it at another look. Another way to look at this is you want to take the derivative of the compositional function. First, you take the derivative of f, and then you multiply that by the derivative of the inner function, which is g. Okay, so let me show you an example. Right, so on the bottom, we have three examples. Let's look at A. Y is equal to ln of 3t. Okay, so the inner function is the 3t, right? This is the inner function. Okay, and let's replace it with some other variable. Let's say z. Z is 3t, right? So we can rewrite this as ln of z, right? Now, when we take the derivative, dy dt, it should be equal to. Now, Notice that when we rewrite the function with z, we actually have just a y and z, right? So if we want to find dy dt, first we need to find dy dz, which is derivative of y with respect to z, right? Because this is z is what we have now. And now next, we still want dt in the denominator, so we are going to use the function that we introduced earlier, or the substitution that we introduced earlier, which is z equal to 3t. And that gives us the relationship between z and t. And using this, we can find out what dz dt is. Okay. Now, if you understand basic multiplication of fraction, you know we can simplify the dz like this, right? Then it just gives us dy dt, right? But this is the idea of chain rule. This is our differential, right? That's our goal. We want to differentiate y. And this extra thing that comes after dy dz, that's your chain rule. That's the extra term from your chain rule. Okay, so let's take a look at this. Dy dz means we need to take the derivative of y equal to ln z. Now, derivative of ln, it just pushes down z to the denominator, right? So we have 1 over z. Okay, multiply by dz dt. When you take derivative of this on the right hand side, you just have a 3, right? So a 3 right here, and then that gives us 3 over z. And what is z? Z is 3t, so it's 3 over 3t, and then you can simplify it. That gives you 1 over t. Okay, so that's part A. Let's look at part B. We have p is equal to e to the negative 0.03t. And again, that's this is your inner function, right? And then e to the power of something is your main function, right? So let's call this z. Right? Z is equal to negative 0.03t. Right? So to find dp dt, right, derivative of p with respect to the independent variable t, we need this z in the middle, right? So dp dz multiplied by dz dt. All right, so dz dt again is going to come from here, and dp dz is going to come from here. All right, so derivative of p, so this, we're actually looking at this, e to the power of z. All right, we have replaced z, replaced negative 0.03t with z already, so this is what we can write it as. And dz dt, the derivative of this. Now on the right hand side, that's just a first degree monomial, right? So we just have a 0.3 left, negative 0.3t. All right, so we need to take the derivative of this, multiply by the derivative of that. All right, let's see what we have. All right, so derivative of exponential with base e, it's still the same thing, right? E to the power of z. And the derivative of negative 0.03t can bring down the power, that's a 1, right? And then the variable will disappear, leaving you negative 0.03. Right? So that comes out to negative 0.03 e to the power of z. And then we can replace z back with the original expression, which is negative 0.03t. Okay, and that's part B. Part C, we have w is equal to 5 times 2r plus 3 squared. All right, so same thing. We are going to identify the inner function. In this case, it's going to be 2r plus 3. Let's call that v. Okay, so V is equal to 2R plus 3, right? And that's going to be acting as our inner function. So we can rewrite this equation as W is equal to 5V squared, right? And it's easy to find the derivative of that, right? So our goal is to find dW dr, the derivative of W with respect to R, right? But now we have to split this up as dW dV times dV over dr, right? So we have introduced these new this inner function right in the middle, so we get two separate differentials in order for us to find our chain rule. All right, so let's see. First, we need to take the derivative of 5V squared with respect to V and multiply by the derivative of V, which is 2R plus 3 with respect to R. Right. So remember that the variable in the denominator that represents the variable we are taking the derivative with respect to, meaning the rule that we're going to apply on the variable. Okay. So let's see. First, that's just a power rule. Bring down the 2, multiply by 5, so you get 10V. Subtract the power by 1, right? 10V to the first power. Multiply by derivative of that. Constant is going to be 0, and 2R, the R is going to drop out, leaving you just a 2. So we have 20V. And go ahead and replace the V back with the original, which is 20 times 2R plus 3. And if you want, you can distribute the 20, giving you 40R plus 60. Okay. And that's it. Now, I know this can be a little trickier understanding chain rules, but I do strongly suggest you to look over these 3 examples again if you're still a little confused. And next, let's look at some more examples. Okay, let's try this. Y is equal to ln of e to the x, and we want to differentiate this. If you want to try this one on your own, feel free to pause the video now and try to work it out. Okay? So first things first, our inner function is going to be this e to the x, right? And let's introduce another variable. Let's say z is equal to e to the x, right? Then our function will look like y is equal to ln of z. Okay, all right, and we're ready. So dy dx. Now, dy dx is a little hard to find, right? Because we have a bunch of function in here. So we're going to introduce z again. So it's going to be dy dz first, multiplied by dz dx, right? So dz dx, and again, will come from this red equation up here. Right? This term will come from taking the derivative of that, and this one will come from taking the derivative of that, right? Now, let's go ahead and do that. Dy dz, right? Derivative of ln z, it's just going to push the z down to the denominator, right? And multiply by dz dx. So e to the x, derivative of e to the x is still e to the x, right? So like that. And then that gives us e to the x over z. Now let's replace z back with its the original expression, which is e to the x. And e to the x over e to the x, that's just equal to 1. Okay, and we're done. All right, next we're going to look at product rule and quotient rule. So this is when you have you want to take the derivative of functions multiplying together or dividing together. Right. So here are your formulas. So let's say I want to take, I have a function that is f times g. Right. Then to find the derivative of the function, all I need to do is I take the derivative of one of them first, let's say f, right? So f prime. times g, and then put the derivative on the other function, and that'll be f times g prime, like that, right? Notice that we have two terms, and prime is on a different function on one of them, right? And that's the product rule, is when you have two functions multiplying together. Okay. All right, and now let's look at one example. All right, let's say I have a y is equal to e to the 2x times x squared. Right. Actually, let me rewrite it. I'm going to write it as x squared times e to the 2x. All right, so we have two functions, two different type of function that requires different types of rules, right? First, we have a polynomial, right, or power function. And next, we have exponential function, right? So let's say I'm going to call this f and this g. Then, to find the derivative, dy dx, that's going to be f prime g plus g prime f. So f prime g plus f g prime. All right, so let's see. F prime, so f is x squared. So f prime, the derivative of f will be 2x, right? Bring down the power, subtract the power by 1. And g is e to the 2x, and g prime will be copy the constant down, multiply by the same thing, right? 2 times e to the 2x. That's exponential rule, all right? And all we need to do is put everything together in here. F prime times g, that's 2x times e to the 2x, plus fg prime, so x squared times 2 e to the 2x, so 2x squared e to the 2x. Okay, and that's it. All right, next let's look at quotient rule, right? So if you have f over g, right, in the form of rational functions, to take the derivative of that, first, in the denominator, you will have g squared, right? And then in the numerator, now this is going to be very important. In the numerator, you will have f prime g minus fg prime, right? So like the same thing with product rule, but instead of plus, you have minus here, right? And since it's minus, the order does matter, right? You need to take f prime first and then g prime afterwards. So the way I used to memorize this is I'm gonna write it down again and walk this through with you guys. All right, so we have, okay, quotient rule, f over g prime. First, I start with g squared in the denominator, and then the first term g is going to stay as the original, and then f prime, it's a minus, and then I just put the prime on the other one, which is going to be fg prime, like that, and that's your formula. Okay, and again, let's look at an example together. All right, so let's say I have y is equal to ln x over x squared. So the numerator, that's my f. Denominator, that's my g. And again, let's find out what f prime and g primes are first. Okay, so f prime, ln x, just push the x down to the denominator. We have 1 over x. And g prime, the power rule, bring the 2 down. Subtract the power of x by 1, which is just 1 now. Okay, so we have f, g, f prime, and g prime. Now we're ready. Dy dx is g squared in the denominator, and then f prime g minus fg prime. All right, let's fill in this out. I like to take care of the denominator first, g squared. So x squared squared, f prime times g, so 1 over x times x squared, minus fg prime, ln x times 2x. All right, and let's see what we have. So this is just x minus 2x ln x over x squared, that's x to the fourth. Okay, and that's it. Okay. And again, feel free to try this one out on your own again, right? But for product rule and quotient rule, all you're doing is fill in the formula, right? Find out what f and g's are, find out what f prime g primes are. Once you have all these 4 pieces of information, right? Once you have all these 4 pieces of information, just plug them into the formula for quotient rule, and that's it. Even though the video for 3.2 to 3.4 is fairly short, but there are a lot of information in here, and actually takes a while and a lot of practices to master these 3 rules. So definitely try these out. Try out some homework problems, and we will have a lot more practice on Zoom together. And that will be it for today. Thank you very much.